Yes, sir. I'm new, sir.
You are attending it for the first time.
My name is Jaisai Rishikesh.
Okay. So those who are attending for the first time, can you post that in plus? Please put you are attending it for the first time, so I'll be able to track you. All those students who are attending this class for the first time, please say that I am new to this class. So I can see a couple of students, more than two, in fact. Okay.
Sir, I am also joining, sir. New one. I am attending class.
Okay. So I can see quite a few of you are new to this class. So which classes are you from? Are you from class 6, 7? Which classes are you from?
Class 6, sir. I am from 6th, sir.
I am from 6th, sir.
Most of you are from class 6.
Sir, from 7th class.
Sir, I am
From 6th class.
Okay.
Student spelling.
So I would encourage you to go and watch the previous classes in YouTube after finishing this lecture. So you will get an idea about what we have covered. So we have only touched upon some basic concepts, but it is very important that you follow up. So please go and watch the YouTube channel for practically. It will give you all the Vedic mathematics classes there.
Sir, you can mute all, sir.
So I think we are ready to start the class. So hope you are comfortable. So we'll move on with this
Please
scheme.
increase volume, sir.
Okay, sure. I'll try to speak a little bit louder. Is it all right now?
Okay, sir.
Okay. So I'm going to mute you all as of now, and we will open the floor for question in the last 5 minutes. So in the meantime, if you have you will be allowed to chat that in the chat box. Okay. So I'm going to mute you all. So please spell out any issues in the audio in the chat box. Okay. So today's topic is going to be subtraction, and we title this topic as all from 9 and the last from 10. So this is a very interesting sutra. So for those who have come for this class for the first time, Vedic mathematics consists of a large number of sutras. Sutras meaning formulae. So this is a Vedic sutra or a formula. So unlike the mathematical formula where you will see equations, in Vedic mathematics, what you have is some formula that is written in worded language. Like here we have talked about some formula that is in English, but actually these Vedic sutras are in Sanskrit. So we will deep dive into some of the topics that we covered in the previous classes, so that it will become a revision for those who have attended already, and it will also put this other students who are coming here for the first time into some perspective. So let us jump right in to the class today, and we are going to start with this mathemagic. So this is all about a puzzle where we will introduce how we can write numbers along the perimeter of a triangle. Okay. So we are ready to start. We see a triangle, and in the middle there is a number that is written. Okay. So the goal here is to fill in all these circles with numbers 1, 2, 3 up to 6. So you can use these numbers. Now the whole idea is that along any side of the triangle, you should have the sum equal to 9. Okay, so that is the goal. So how do you do that? I write a number, say 1 here. Maybe I'll write 2 here. What I should write here for getting 9? I should write 6. but then I will be running into trouble for the other two boxes. What will I fill here? I can fill 3 here, but then I have to put some number here as well. So this does not go well. So what I have to do is I have to plan this out a little bit carefully and rewrite the numbers a little bit more carefully. So let me erase this one and this one. Instead, what I'll do is I'll just write 2 in the bottom circle. Let me just try this pen. I think there is a technical issue. Okay, so we get a 2 here. Now we can comfortably write 6 here. Okay. Now, just as a matter of trial and error, let me just put 3 here. What is the number that is remaining? 2 plus 3 makes it 5. What is remaining is 4, which I can put in the middle. So we have got 2 sides and only one number is left, which is that number 5. So let us write 5 first and check whether the sum of the digits in that particular line of the triangle is also 9. So 3 plus 5 is 8. Again, you'll get 1. Now you can do some other tricks. You can rotate these triangles in any fashion and make 1 appear below, 2 here, and 3 above. So you can rotate in 3 different manner to get the same result. Let us go into a little bit more complexity by making the sum equal to 10. The same numbers are there. Remember, you have to use only numbers from 1 to 6. Same numbers appear. So obviously you can start with 1. Now here you have to be little bit choosy on what number you have to put here. So when I put 2 here, I'll get maximum of 6. So I should put a number which is greater than 2, which is 3. Now I can write 5 here. Is it right? No, it is not right. So I should erase that 5. So let us erase that number 5. Okay. So what should come here actually? It should be 6. Let's write 6 then. I think there is an issue with the pen here. Okay, so 6 makes it 10 along this side. What should I put here now? Let us put 5 here. So if it is 5 here, we already got a 6. So we have to write 4 here. Now the only remaining number is 2, which again makes the line in the bottom also equal to 10. So along each side of this triangle, we have got the sum equal to 10. Now you will observe a pattern. What is that pattern? All the numbers in the edge is an odd number. Are you all familiar with odd numbers? So odd number is a number that is not divisible by 2. So 1, 3, and 5 are along the edges of this triangle. And you can see all the even numbers along the middle. So even numbers in the middle. So this is a very interesting result that we have got to make a perimeter of 10. So this is what is called as a perimeter. You add all the 3 sides. So the perimeter is actually 30 because each of the sides is 10. So to make that as a perimeter, you have to choose odd numbers along the edges, and along the middle of the edges, you have to choose even numbers. So I have one more puzzle left, which is to come up with 11 using the same numbers. So this I'll post after this lecture as a quiz. So you have to try it at home and tell me the result tomorrow. So this is a little bit of warm up, and we'll go a little bit more into what we have seen in the last class. So this is checking subtraction. So taking into account there are some newcomers in this class, I will explain digit sums a little bit more. So the digit sum is a tool that you can use in Vedic mathematics to check whether the results that you have computed is correct or not. Okay. So this is how the digit sum appears in the 9-point circle. So this is the 9-point circle, meaning that you can imagine this to be a clock, and the clock has the central figure as 9, 0. I'll explain shortly why 0 is put here. You have 1, 2, 3, 4. 5 is appearing in the opposite side as 4. And 6 is appearing in the opposite side as 3. And 7 is appearing opposite to 2. And 8 is appearing opposite to 1. Now this has got significance. What is the significance? The significance is nothing but they add up to 9. Each of these opposite numbers add up to 9. So that is the importance of 9-point circle. And using this 9-point circle, you can find what is called as the digit sum of any number. So let me take an example. 18 is a number, a 2-digit number. I want to find the digit sum of 18. What is it? So digit sum is 1 plus 8, and this is equal to 9. Another name given to digit sum, some of you might know already, is Navashesh. So the meaning of Navashesh is what remains after dividing by 9. So when you get this digit sum as 9, the remainder that you get by division by 9 is 0. That is why we have put this number 0 along here. Is that clear? So now we will use this idea of digit sum to check whether the subtraction operation is done correctly or not. So I'll show you 4 problems appearing in this slide, and you have to tell me whether the digit sums tally for the subtraction. So the first problem is this: 565 minus 177. So the answer you don't have to compute, it's given to be 388. Now you have to just verify whether this is correct. Last time we did a manual verification where we added 388 back into 177. That is one method, but there is an easier method using digit sum. How do we calculate the digit sums? So first take the number 565. So what is the digit sum? Add all the digits. 5 plus 5 is 10, plus 6, which is 16. So 16 has a digit sum of 7. 177, this adds up to 15. So digit sum is 6. Now to check the answer, you have to do the digit sum 7 minus 6. What is that? That should be 1. Let us verify whether the digit sum is actually 1 or not. So 388, this is adding up to 19. The digit sum is what? 388. So 16 plus 3, which is 19. So 20. The digit sum should be 2. Are we making any mistake? Let us see. So 14, 15, this is correct. So let us add it back. 8 plus 7 is 15. There is an addition. There is 16. But this seems to be right. So are we making any mistake? So we go back to here in this. 7 is appearing here. 7 minus 6. What you should do is start from this point and go in the reverse order. So 7 minus 1, you will reach here, minus 2, minus 3, minus 4, minus 5, minus 6. So 7 minus 6 is indeed reaching 1. So we have not made a mistake there. So what about this? 8 plus 7, this is also not a mistake. So what we understand is that digit sum does not apply everywhere. So you will have to be a little bit careful. Let us try this one. 7 minus 6, which is 1. We have verified this already. Now, what about here? 713 minus 347. Here we have the sum of digits as 11. So digit sum is 2. What about 3, 4, and 7? Here is 14, which is 5. 366 has digit sum 9 plus 6, 15, which is 6. So let us verify this. We start from 2 and we have to come backward. How many positions? 5 positions. So from 2, 1. Then we come back here, which is the second position, third position, fourth position, fifth position. So this in fact is correct. We have verified it using digit sums. So let us check once again the reliability of digit sums here. 8 plus 3, which is 11. So digit sum is 2. 4 plus 7, again 11. So digit sum is 2. Digit sum of 3 plus 6 is 9 or 0. 2 minus 2 is 0, which is in fact correct. So this subtraction is correct. This subtraction is correct. What we have mentioned here is that there is a possibility of verification error. So we just put a dot to that, and we shall repeat about this in a later section in this video. So hope the digit sum computation as of now is clear to all the newcomers. Let us proceed. This time we will do a little bit of subtraction. So in the previous slide, we have done subtraction and the checking. So in this slide, we are going to do longer subtractions. Again, we'll take the help of digit sums. So do the following. So try to do it in the mind. I want all of you to try this in your mind. So the method that we'll adopt is from left to right. Now, what does that mean? So conventionally, students might have been taught about subtraction from right to left. Here, we encourage students to start from the left. Why? Because of the simple reason that the largest place value comes here. So this is the most significant digit. So if you want to give an approximate answer, it is always better to start from the left. And in Vedic mathematics, we encourage you to start from the left. So we have this idea of home team and the visiting team. So home team and visiting team. So I just want to know how many of you know what is a home team? So some of you might have been watching cricket, so you might know. So if you know the answer, please post yes if you're familiar with home team and visiting team in the chat box. Okay, so some of you do not know. So home team is a team that is playing in its home ground, you can say. So if the Indian team is playing within India, it is called as a home team, and visiting team is a team that visits the place who is competing against the home team. So you can view subtraction as a home team versus a visiting team game, like a match. But the criteria here is that you should always put a provision for the home team to win. Home team is the first number here. I'll write HT for home team and just VT for the visiting team. So the criteria is that home team should always win. So you can consider each of these digits in each place as to be batsmen, and they have scored some numbers, some runs. Now, similarly, the visiting team batsmen have also scored some numbers. Now you have to find the difference to see who has won. So in order to help the home team win, the bigger players meaning the players who are in a higher place value, have to share their runs with the players who are coming next, or the players who are younger than them. So you see, the first place is 3. 3 minus 1, it is done okay. 5 minus 1, also there is no problem. But when it comes to 5 minus 8, you will see that a problem arises. It is a negative number. So the elder player in this place has to give his 1 run to this person so that he can win over the batsman in the same place. Similarly, it goes like that. So let us see or play this game once. So 3 minus 1, you can comfortably put 2 because the next player does not want any help. But here you have to be careful. 5 minus 1 is 4 actually, but you should write 3 because this person has helped the next one. What is the help given? He has given only 1 help. So the next person will get a 15 here instead of a 5. So 15 minus 8, you can put 7. But before putting 7, you have to see whether the next batsman needs help. Next batsman is 6. So 6 minus 2, there is no problem. So you can directly put 7 here. Then 4 here. But before writing 4, you have to be careful here. 7 minus 8, it should need some help. So you should put 1. And you should put 1 less here, which is the number 3. So 17 minus 8 is 9. So this is the answer. Let us go and do once again, one more sum. So this is a subtraction of 4-digit numbers. So you can see the 4 batsmen in the home team and 4 batsmen in the visiting team. So 8 minus 3, no issue. But you can see the issue coming next, 0 minus 8. So here there should be a carry and you should put 2 here. Again, there is an issue coming in the next batsman. So you should put 1 here. And again, you have one more issue, which is 18. So you should put 1 less here, which is 6. And here it should be 9. So this would be the answer. All this you can do it mentally. So let us go for one last one. Here we have a 5-digit number taken away. A 4-digit number taken away from a 5-digit number. So one way is to just add a 0 here. So you can see the first batsman was out in the visiting team in the first ball or something like that. Now here also an interesting thing comes. So 1 minus 0, no issue. But the issue comes here, 4 minus 3 does not go well. So you have to borrow a 14 here, put 0 here. 7 should come next. There is no issue with the next batsman. So you can directly go ahead with 7. 2 minus 1 is 1, but you have to check for the next batsman. 8 minus 4, no issue. So here is 1. 8 minus 4 is 4, but you can see the next batsman needs some help. So here I'll write 3 and here I'll write 7. Let us check the middle answer using the Navashesh idea that we learned in the previous slide. So Navashesh, just to revise, is the digit sum, which means you have to add all the digits and represent it by a single digit. So you write 8 plus 8 is 16, but that is not a single digit. To make it a single digit, add the digits of 16, 1 plus 6, that is 7. Now, what about this? 3 plus 8 plus 3 plus 9. It's a long addition. But we have learned that you can cast off 9s. Whenever a 9 appears in the digits, you can cast it off. You need not include that in the digit sum. So you cancel this 9. Next, you have 3 plus 8 plus 3, which is 14. Digit sum is 5. What about here? 2 plus 1 plus 6 plus 9. What is it? 9 plus 9. So the digit sum is 9. You can see there is a calculation mistake. I urge you to check this calculation once again at home. So here are some practice questions once again for you. So because of shortage of time, I'll just put these practice problems as assignments after the lecture. So you can check them in the practice section in your Practically app. So now we come to this interesting puzzle. So this was given as a problem to solve in the previous class, and almost 80% of you had done this incorrectly. So this puzzle is to encourage you to observe more about a mathematical problem. So the power of observation lies in looking into the details. So here you can see this is a figure problem. Many of you have answered this as 12, but the answer is not 12. So let us see how we can solve this. Most of you have found out apples as 6, or apple is 6. What about bananas? You should observe that there are 4 bananas. So I'll just write, so 1 apple, there is no S. So 4 bananas. What is the score of 4 bananas? Can somebody type in the chat box? What is the what is the cost of bananas? Okay, somebody has told 4. Let us verify. Yes, it is indeed 4 because this apple is 6. So 2 sets of 4 bananas is 8. So 1 set of 4 bananas is 4, which is absolutely right. So 4 minus these 2 cherries is 2, which means the 2 cherries is equal to 2. So coming to the final row here, we have 2 cherries plus 1 apple plus only 3 bananas. You should be careful now. Now the cost of 1 banana is 1. So 3 bananas is 3. So this should be 3 plus 6, 9 plus 2. The final answer should be 11. I can see many of you have posted this rightly in the chat box. So congratulations for finding that. So this is to just explain about the looking into details. You should enhance your observation power by solving more and more puzzles. So let us move ahead. Now we are going to go into this sutra which we saw in the title. What is the sutra called? All from nines and the last from tens. So we will see this, how the sutra can be used. So consider this number 876. So we are going to do this sutra here. All the digits except the last. So by the last, I mean the number 6, the digit 6. This is the last. So all except the last you should subtract from 9. So 9 minus 8 is 1. 9 minus 7 is 2. Last one you should subtract it from 10. So you get 10 minus 6, which is 4. Now what is this represent? What does this represent? It is just representing a complement to the number 876. So we have learned about complement, how we can see what is the remaining number in an abacus if you arrange the number in the place value corresponding to that particular number. So let us do another exercise here. 54. The last digit is 4. I'm just squaring it for you to remember this is the last digit or the last. So what should you subtract from 5? So 9. 9 minus 5 is 4. You should subtract 4 from 10 because that is the last digit. So this is 46. Let us do one more. This is a single digit number. So what you should do? There is only a single digit. So this is the first and the last. So you take this as the last digit. So you should do 10 minus 9, which is 1. Now what you can see is that if I add 124 back to 876, what is the answer that I get? I get 1 followed by 3 zeros. You can verify for yourself. 54 plus 46 is 1 followed by 2 zeros. And 9 plus 1 is so simple, it is 10. So you can see that we are connecting to the base by doing this operation of all from 9 and last from 10. Now we'll see the applicability of this result in subtraction. So can you calculate what is 1000 minus 864? Now we have just written that if you add 876 to 124, you will get 1000. So if you subtract 1000 from any other number, you should get this as all from 9s and last from 10. So you can directly apply this sutra here. So there are 3 digits here. The first digit is 8, so that you should subtract from 9, which is 1. 9 minus 6 is 3, and 10 minus 4 is 6. So how easy it is. You can just avoid those carries, which was a menace for you to do. This you can just do it mentally. Very useful when you are going to shops. So if you buy some set of items, you give some 500 rupees. You want to calculate the balance amount that you should get. You can do everything in your mind. So what is 1000 minus 307? Again, you can apply the same sutras, all from 9 and last from 10. So 9 minus 3 is 6. 9 minus 0 is 9. And 10 minus 7 is going to be 3. What about this? Here you have a 4-digit number, but the same rule applies. You just have to identify the last. From all the remaining numbers, subtract 9. So this is 3, 4, 7, and 7. You can see how quick the answer came. Here is the last one, 100 minus 63. This is a 2-digit, so it's an easy one to do. So without looking, everyone can guess this is 37. But you could have applied this rule again, all from 9s and last from 10. So here are a few practice puzzles. I will leave you to work with them at home. Let me straight away jump to a word problem. So here you can assume some person is running a garment factory, and this garment factory is producing some set of garments per day. So we are producing some kind of trousers per day, and out of this, certain number is exported. It is traded to somewhere else. So you want to find how many you have to store in the factory. So can you put the answer in the chat box? So this is a direct application of the sutra that we just learned. Can you post the answers on the chat box? So I'll just wait 30 seconds for you to just calculate this in your mind. Yeah, I can see Hemant has answered. Let us see if the answer is right or not. Waiting for a few more seconds for the others to just speak in. So you just have to apply the sutra that we have just learned, all from 9s and the last from 10. Yes, I can see answers pouring in. So congrats to Elena, Sai, Rani, Archana, Krish. So I'll just tell you the answer. So you can see that what is this number? 1 followed by 5 zeros. This is a 5-digit number. So only thing that you have to verify is whether the number of digits in the operation that you're going to do is same as the number of zeros from which you have to subtract. So that is all you have to check. There are 5 zeros here. There are 5 digits here. So let us do all from 9s and last from 10s. So we get 6, 5, 0, 7, and 5. So most of you have got this right. So let us go to the second word problem. Here I'll give you a little bit more to think. So Susan and her mother had gone to the supermarket to purchase the following items. So toothpaste is costing something, rice is something, noodles is something, cupcakes are something. Now, the mother paid 500 rupees and asked Susan to collect the change, the remaining. So how much should she receive? So I want all of you to try this, and I'll give again another 30 seconds for you to answer that in the chat box. So you can try a little bit of mental mathematics. If you are not able to do that, do not pick up a calculator. You can pick up a paper and do that. So you will not be given a calculator at the store. Okay, so I don't see any answers, but I'll still begin to give you the answer. So the first easiest thing is to start with the decimal places. You add all the decimal places. So 50 plus 25 is 75, plus 15 is 90. So you should get 95 paise in the sum. So, yeah. Now, what about the others? Some observation will let you know that 56 and 144, they add to 200. And there is 183. So that makes it 383. 383 plus 120 is 503. So total is 503.95. So in fact, the shopkeeper would ask you to pay close to 4 rupees again. So what should Susan say? She should say her mother to pay another 3.95 rupees. So I can see a lot of answers. So thank you for the students for participating. So let us go ahead. Now we'll see that in the previous problem, what we saw is what is the difference between a number from a local base. So in the beginning, we have explained how to compute numbers from a base that is 1 followed by many zeros. But in all cases, you may not encounter that. So here is how. So sometimes you have to calculate what is 700 minus 66, and not always like 100 minus 66 or 1000 minus 66. So to do this, what you have to do is, you can still work with the all from 9s and last from 10, but here you have to consider the last figure little separately. So the first figure, you have to consider it separately. The first figure is 7. So the rule that is particularly applied is you subtract 1. So that becomes 6. And then you can apply all from 9s and last from 10s. So this is going to be 6, 3, 4. Let's do a few more. So this is very similar to the home team and the visiting team example that we have just put earlier. So I want you to try some of these. Let me just pick up this, the B part. The remaining you can try at home. So you can see this is a 3-digit number, but here you have a 5-digit number. But fortunately, there are only 3 zeros. So what you have to do is the same trick apply. You can consider 17 as a single number and subtract 1. So that will be 16. Then apply all from 9s and last from 10s. So this is 3, 4, and 6. Okay. So there are some more practice problems which I will leave you to work from home. Now I'll just show some other variations. So here there is another variation which is similar to the example that we just did a second before. So here we have 5000 minus 47. This is a 4-digit number. Here you have a 2-digit number. So in this case, what you can do is you can put a 0 here and subtract 1 off from 5, which is 4. Then apply all from 9s, last from 10. This is 9, 5, and 3. So isn't it very easy? You don't need anything. You don't need even a pen and paper to compute this result. So the sutras are very powerful that you can do every calculation directly in your mind. What about 40,000 minus 33? Again, the same rule. You can put 2 zeros here. So it matches the number of digits. If you add 2 zeros, the number of zeros in the first number, which is 40,000, is equal to the number of digits that appear in the second number. So you can apply the same rule. You have to subtract 1 from 4, which is 3. The remaining numbers are 9, 9, 6, 7. Is that clear? So we just applied the sutra. So what about subtraction from decimal numbers? We have already done an example in the worded problem. Here is one more for you. Let me just do this one. So 1 minus 0.763. What is this? So you can consider this as 1. This 1 you can write as 1.000. So this is same as calculating 1000 minus 763, but instead of writing the final answer as it is, you have to just introduce decimal place. So what is this going to be? 0.237. Isn't it wonderful? 10 minus 6.77. This you can write it as 10.00 minus 6.77. So what is this? You can apply the all from 9s and last from 10s. This is 3.23. I have some practice that will be available to you after this lecture. Okay, now I'm going to a puzzle. So we have around 7 more minutes. So I'll just do this puzzle, which is called as the zigzag subtraction. Then I will let you know what is the puzzle that we are going to do for the day. And then I'll take the questions up. So the zigzag puzzle is very interesting. So you know what is zigzag? It is going here and there. So that is what is called a zigzag. So now you have to find out what is the answer to 4 multiplied by something in brackets. And what is in bracket? You have alternating signs of plus and minus. I don't know if you have encountered negative numbers. 6th standard students may not have. But if you are confused with negative numbers, you can see them as subtractions. So you can see this as 2 minus 1, 4 minus 3, 6 minus 5, etc. etc. So if you observe it in this manner, you will get an answer. I want you to post your answers in the chat box. So what is the answer that you will get? So I see an answer minus 4, which is not right. Somebody has posted 1000. The answer is seemingly not right. Okay, let us see. The answer is 0, no. Minus 1000, no. Okay, so let us see what is happening here. So what I suggest is you combine two numbers. How many numbers are there in bracket, by the way? Avoid the symbols plus and minus. You can count numbers from 1, 2, 3, 4, etc. up to 1000. So there are 1000 numbers in the bracket. There are 1000 numbers inside the bracket. Now what I want to do is combine two adjacent numbers. You know what is adjacent numbers? Numbers that are close. So you can do 2 minus 1, 4 minus 3, 6 minus 5, etc. etc. Okay. So if I do 2 minus 1, it is 1. If I do 4 minus 3, it is 1. 6 minus 5 is 1, etc. This will go to 1000 minus 999. So that is also 1. So how many such numbers are there? It is 500. Why? Because I have combined two numbers. So it should be the half of 1000 numbers or 500 numbers. So now you can easily do what is 4 multiplied by 500. This is 2000. And that is the answer. So let me just check once again in the chat if somebody has got. Yes, some people have got. Divyasri, I can see, has written that. Okay. So congratulations whoever has got. So let me just skip bar numbers and I'll introduce the bar numbers tomorrow. It is another way of doing subtraction. And let me come to the puzzle. So this puzzle I'll give you as a take home. This will appear in the practically app. So you can see a building. You can see a plan of the building here. And there are many rooms in this building. Now some rooms are painted. So all the painted parts are represented here. So you can see that room is painted. You can see here another room is painted. And all these gray boxes are painted rooms. So now you have to calculate what is the area of this building that is not painted. So all the white areas are not painted. So you have to explain what is that particular part of the building or the percentage. You can give it as a percentage area. If the total area is A, what is the percentage area that is not painted? So is the puzzle clear to you all? You need to think a little bit in terms of fraction. So that is a hint that I can give. And here you have another puzzle. I'll just explain it before I take up questions. So here you can see a circle. This circle has got an area of 120. I am introducing some smaller circles inside this large circle. And the radius of this middle circle, one that I'm pointing in red now, is half of the larger circle area. And the area of the small circle here is 1/4 of the large circle area. So now you have to see what is the portion or what is the area of the portion that is shaded in gray. So this is applying a little bit of subtraction and a little bit of fraction. So this is a very nice way of learning geometry. So you are not specifically given the radius of the larger circle, but you are only given with the area, but you have to compute some manipulated version of the area. So I urge you to try these two puzzles at home and come back and answer them in the quiz section that will appear in today's lecture. So now I will open the floor for questions. I will allow you to unmute yourself and ask any question, or you can just raise your hands. Yes.
Sir, tomorrow also class will be there, sir.
Yeah. Can you repeat the question?
Tomorrow also class will there, sir.
Yeah, class is there tomorrow as well.
Sir?
Yeah.
Sir,
please
but
go
that
ahead.
maths class and science class, they said tomorrow is holiday.
So you can check within the Practically app. As far as I'm told there is class tomorrow.
Yes, sir, it's there in the upcoming meetings tomorrow at 10:25 a.m.
Yeah, it is there. Yeah. So you can just watch out for tomorrow's lecture.
Okay, sir.
Sir?
Yeah.
Sir, now class completed, sir.
Yeah, today's class is completed. Yeah.
Sir, can you explain geometric puzzle again?
Sir,
Okay,
can
sure.
you explain geometric puzzle again, sir?
Okay, yeah, sure. So the puzzle is as follows. So you can see this large circle here. It has got an area of 120. Now to this large circle, I am putting 7 circles. I am cutting. You can see I have carved out some circles from the larger circle. Now the details about the smaller circles are given. So the radius of this circle is, if the radius of the true circle was some r, let me call r as the radius of the large circle. Everyone is familiar with radius? Are you familiar with radius?
Yes, sir.
Okay.
Yes, sir.
So radius of this middle circle that I am just pointing here. So this circle has radius r by 2. And the radius of the smaller circle is r by 4. So you know what is the relation between the circle radius and the area?
Sir? Yes,
What
sir.
is the relation?
Yes, sir.
Yeah, what is the relation? This pi r squared, right? Everyone is clear with the area of the circle. Now, what is being asked is, what is the area if you subtract the area of the larger circle minus the circles colored in white? Got it? So you have to subtract larger circle area minus whatever circles are there in white.
Okay, sir.
Okay, that is all that you have. So
Sir?
take your own time at home to solve this. It will be appearing as a quiz after today's lecture. Yeah.
Sir?
Yeah, please ask the question.
Sir, can you please explain sutra subtracting process by checking, sir?
Okay. So I'll just go to the first slide or some slides before. Okay, let me just do this. Okay, let me just do with this. So here we have already found the answer. 5000 minus 47 is 4953. So how do you check whether this is right? You find the digit sum of 5000. Can you say what is the digit sum of 5000? What is the digit sum of 5000? Can somebody say? It is 5 because there is only one digit. All the remaining digits are 0. Digit sum of 47 is, actually the sum of digits is 11, but digit sum is 2. Isn't it? So 5 minus 2.
How can it be 2, sir?
Yeah. So how do you compute digit sum? 47, you add the digits. What is it? 4 plus 7. What is it?
11.
11. But this is a 2-digit number. But digit sum is always a single digit number. So this again you have to find the sum of digits. 1 plus 1 is 2.
Oh, okay, sir. Okay, sir.
Okay, got it? Got it?
Got
Okay.
it, sir.
Now to check the answer, you have to see whether this number has got digit sum 5 minus 2, which is 3. That is simple. 4 plus 5 is 9. and there is another 9. But whenever you get a number 9 in the digit sum, it doesn't matter. You can eliminate that 9. We have already discussed that property. So you can see if somebody is new to this topic, you can go and refer to a previous video. So the digit sum is 3 here. So we have verified this answer is correct.
Sir.
Yeah, please ask.
Sir,
Yeah,
please
please
explain longer subtraction, sir.
Okay, so I'll just explain you the basic idea. You can go home and try the practice exercise because we are exceeding time a little bit. I'll just give you an overall idea about what we explained here. So what we explained is in terms of a home team and a visiting team. Okay, so this is basically subtraction we are doing from left to right. You start from digits in the left, which is the leftmost digit here, 3. And the leftmost digit below is 1. Now you do 3 minus 1, which is 2. Next number also you look, 5 minus 1. There is no problem with that number. So you can correctly write 2 here. Now 5 minus 1 should have been 4, but you see that in the next place, 5 minus 8 is coming. It is not possible to do unless you carry a number. So that is why you have to write 3 and you have to do 15 minus 8, which is 7. Next place is 6 minus 2, which is 3, which is 6 minus 2 is 4, but you have to write 3 because you are expecting a carry in the next place. So this is very similar to the carry technique that you are using in ordinary subtraction. But tomorrow I'll explain you another easier method which avoids all kinds of carry, and that is what is called as bar numbers. So until tomorrow's lecture, I would be patient with longer subtraction. I will make you longer subtraction much more easier to do, and that you can do in your mind itself. Okay, so don't worry so much on longer subtraction as of now. So
Okay,
I would like to conclude this lecture and take up more questions, if any, in tomorrow's lecture. So thank you.
Okay, sir. Thanks, sir.
Bye. Bye. Thank you, sir.
Bye, sir.
Thank you, sir. Bye.
Bye, sir.
Thank
Have
you,
a good
sir.
day, sir.